Here's a problem where we're going to use trig substitutions to solve it. This one is a definite integral. And looking at what I have here in the problem, the square root of a squared minus x squared. So that one, I'll use this trig substitution. X equals a sine theta. And I also have to remember to find dx. Dx, the derivative of a sine theta, the derivative of sine theta is cosine theta. So dx is a cosine theta d theta. And let's just get all this substituted into the problem. Now, I'm changing the variable, but you know, I'm seeing 0 to a. Those are values for x. And I'm going to leave them 0 to a and just change things back to x. So I'll do 0 equals a value for x. A is some value for x. And I'll have x squared. That will be a sine theta squared. And then the square root of a squared minus a sine theta squared. Dx is a cosine theta d theta. Let me separate I've been calling that my thinking part right there. Now let's simplify this. So 0 to a, again, those are values for x. A squared sine squared theta times the square root of a squared minus a squared sine squared theta times a cosine theta d theta. So the integral from 0 to a squared sine squared theta. Under the square root, we're going to take out that a squared, and I'll have 1 minus sine squared theta. Because this square root is multiplication, I have a squared times 1 minus sine squared theta. Because it's multiplication, I can do, I'm going to put a little dot there for emphasis, times. I can do the square root of a squared is a, and then, in fact, there's an identity for 1 minus sine squared theta. It is cosine squared theta. So we're going from 0 to a squared sine squared theta times, well, the square root of a squared is a, and 1 minus sine squared theta is cosine squared theta. And I'll just write the rest of what I had on that problem. Now, we'll have square root of cosine squared theta is cosine theta. So I have 0 to a squared. Let's collect all these a's at the front. A squared times a. And this is sine squared theta times cosine theta d theta. And this will be cosine squared theta. So the integral from 0 to a squared times a, oh, that should have just written a to the 4th. Okay, sine squared theta, cosine squared theta, d theta. And I'm looking at what I have here, and I'm thinking, okay, I'm going to do some sort of use trig identity, and I'm thinking in my head these sorts of things. Would it work if I try to do some u substitution? Could I factor off one of these trig functions? And you know what? That's not going to work on this problem, because I'll run into a problem where I'll have some trig function. I'm not sure, I won't have a way to handle it. So I am thinking of the two identities I gave you for sine squared theta and cosine squared theta. I'm thinking of the ones we did, not the first one, not the Pythagorean identities, but I'm thinking of those other ones, which was this. I'll write them on the side. Sine squared theta is 1/2 times 1 minus cosine 2 theta. And cosine squared theta is 1/2 times 1 plus cosine 2 theta. So I'm thinking of those two. Those are the ones I'm going to put in for these right here. And let's do that. So we'll have this.